In this video, we shall be looking at understanding the common security vulnerabilities in Ethereum smart contracts and practices to mitigate these risks. We will look at techniques for writing secure and robust smart contracts. We will be exploring the fundamentals of smart contract security, the challenges and risks associated with blockchain based applications. Then we shall understand the most common vulnerabilities in the smart contracts. We will also discuss the best practices for implementing secure smart contracts, including code auditing, testing, and deployment strategies. We will look at writing secure code and using security tools and conducting security audits. Then we will look at two examples of real world exploits and look at the significance of comprehensive testing strategies. It is important that we write secure smart contracts for the following reasons. Since we cannot change smart contracts once deployed, it becomes very important that we write secure code. Unlike traditional software, faulty code can lead to irreversible damage. Smart contracts also help in transfer of cryptocurrency, therefore making it a very attractive target for malicious attacks. Since the smart contracts are deployed, they automatically keep on executing the code written. Therefore, it is important the code we write is foolproof. Smart contract security is like the security of a bank vault, where any vulnerability can lead to significant losses. Common vulnerabilities in the Ethereum smart contracts are like weak points in a fortress that attackers can exploit. Reentrancy is a vulnerability in which an external call can recursively call back into the original function before the initial execution completes. Integer overflow is when arithmetic operations exceed the maximum or minimum values of an integer type. Access control issues are when authorized users gain access to restricted functions. In the reentrancy example, in the withdrawal function, we can see that the balance gets updated after the withdrawal. So an attacker can make a smart contract here through which he can withdraw all the amount before the balance is updated. In the integer overflow underflow example, an attacker could exploit the smart contract by causing the balance to wrap around, meaning manipulating arithmetic operations to bypass the logical checks due to the way integers are handled. For example, if we have u int a, which holds value from 0 to 255, and if the value is 255, and even if we add 1 to it, it will become 0 due to the overflow. The best practices for writing secure smart contracts are like building codes and safety regulations that ensure the stability and security of a structure. The checks effects interactions pattern involves first checking the required conditions, then making the necessary changes, and then finally interacting with other contracts or external system. This help prevents race conditions and other vulnerabilities. For example, a secure withdrawal function would first check the user's balance, then update the balance, and finally send the funders to the user. This is an example of how to prevent re-entrancy attacks as shown in the previous slide. Access control is also crucial for securing smart contracts. Contracts should have a clear owner and only allow authorized users to perform sensitive operations. The ownable contract pattern demonstrates how to implement this with a modifier to restrict access to the contract owner. It's also important to validate all inputs to the smart contract. This prevents malformed or malicious data from causing unintended behavior. The input validation contract shows how to validate an each parameter, ensuring it falls within a reasonable range. Here is the example for the checks effects interactions pattern. The contract first checks if the user has a sufficient balance. This is the checks part. Then the effects part updates the user's balance to prevent reentrancy. Then the interactions part transfers the amount to the user. This order ensures that the contract state is updated before any external calls are made. The ownable contract provides a basic and secure way to manage ownership of the contract, ensuring that only the owner can perform certain actions. The only owner modifier restricts access to functions so that only the current owner can call them. The constructor sets the initial owner to the address that deploys the contract. The transfer ownership function allows the current owner to transfer ownership to a new address. It also has a check to ensure that the new owner address is not the zero address. In the input validation contract, the input validation, the require statement ensures that the age provided is within the specified range. If the condition is not met, it is reverted with the message invalid age. We must emphasize writing secure code by avoiding risky patterns. We need to steer clear of coding practices that could introduce vulnerabilities such as unchecked inputs, unprotected access controls, and improper error handling. We also need to use the latest Solidity version. We always use the latest Windows version, right? It is because it has better security performance and newer features. We also need to utilize well-tested and thoroughly audited libraries like OpenZeppelin to handle common functionalities such as fungible tokens. This reduces the risk of introducing custom code vulnerabilities. Writing secure code is like using high-quality materials and following the best construction practices to ensure the durability of a building. We can introduce tools such as MythX, Slither, and Mantico for static analysis and formal verification of smart contracts. Using security tools is like employing advanced scanning and diagnostic equipment to detect structural weaknesses in a building. To use MythX, sign up for an API key and run the CLI to analyze the contracts. Slither can be installed via PIP and run on contract files. Manticore, also installed via PIP, can be used for symbolic execution of contracts. Conducting thorough security audits before deploying smart contracts is of utmost importance. A security audit is like having a team of experts thoroughly inspect a building for any flaws or vulnerabilities. The steps involved in a security audit include a comprehensive review of the smart contract code, testing for known vulnerabilities, and identifying potential attack vectors. This process helps uncover any weaknesses or loopholes that could be exploited by malicious actors. These are some examples of real-world exploits on the blockchain system. These exploits are like case studies of major structural failures, providing valuable lessons for future products. The DAO hack in 2016 resulted in the loss of over $50 million in Ether. The vulnerability was in the contract's code, allowing an attacker to repeatedly withdraw funds. This is like the re-entrancy example. Also, the parity wallet bug in 27 led to the freezing of over $150 million in Ether. This issue was caused by a vulnerability in the wallet's multi-signature contract, which allowed an attacker to gain control of the wallet. This is the access control issue. It is of high importance to do comprehensive testing, including unit tests, integration tests, and fuzz testing to uncover potential security issues. Testing for security is like conducting stress tests and simulations to ensure a building can withstand various challenges. This test aims to offset re-entrancy attacks. It first imports the secure contract artifact. allowing us to interact with the deployed instance. The last block of code with the try-catch structure is used to catch any errors while we attempt to draw one either from the contract. If an error occurs, which is expected, if the contract successfully prevents a reentrancy, the catch block checks if the error message includes transfer failed. The assert statement ensures that the error message matches the expected one, indicating that a reentrancy attack was prevented. So, we looked at how security is paramount in smart contracts since the smart contracts are immutable and it also has the money angle. We also saw common vulnerabilities such as the reentrancy, integer overflow slash underflow, and access control issues. We also looked at various security tools and audits which we can use to build safer smart contracts. Here are some questions which you can try.